away.
Okay, thanks, Rich. And hi, everyone. Thanks for coming out today. I'm going to share my screen here, put some slides up. All right. Now you should be seeing a title slide. Is that
looking good?
Looking good? Let's see if I can switch on the pointer here. Okay. So yes, I'm here to talk about some things going on with Project Pythia. Bit of a fanciful title for what's going to be a fairly informal discussion, I hope. Challenges and progress in breaking down barriers to open science. The list of people on the slide here: John Klein, Ryan May, James Monroe, Orhan Aroglu, Kevin Tile, Drew Cameron, Max Grover, Julia Kent, Rob Ford. These are all folks who currently are kind of the core of the Project Pythia team. I want to emphasize Pythia is a big effort and a big tent. There's a much, much larger group of people that have been involved, that have made contributions, that have come to meetings and had great discussions, that have helped advance things, that have come to our hackathons, that have contributed content, code, etc. So this is very much a community effort. I just can't fit everyone's name on one slide. Let's see. Okay. So I'm not going to spend a lot of time just talking about what Project Pythia is, but if you've never heard of it, this is a funded activity that's meant to create community learning resources and knowledge sharing resources specifically for the geosciences. The Pythia name is kind of having a little fun drawing some inspiration from ancient mythology and the connection to Python. But Project Pythia exists to help geoscientists do their science more effectively. And it's really centered on the scientific Python ecosystem, and more specifically on what we think of as the Pangeo set of tools. I put a slide here. It was more than 3 years ago. I looked back. The last time I talked about Project Pythia at a Pangeo whatever we call these, Pangeo meeting. And Project Pythia at that time was just getting going. And I put this slide up under the heading of why are we doing this? And I thought it'd be helpful to bring it back just because I think not that much has fundamentally changed. I still see this deep need for good quality resources that help people who are working scientists in the field kind of get access to all of these wonderful tools that are advancing rapidly, that help scientists deal with large data sets and do efficient calculations with cloud computing, and otherwise just sort of modernize their workflows. So this slide is meant to represent this barrier between, people who's kind of tech savvy, who figured things out, and a lot of others who could benefit from sort of flattening these mountains a little bit. And that's why Project Pythia exists and why it continues to exist. So to elaborate on that a little bit and to explain a bit of the vision underlying the Cookbook initiative, which I'm going to spend most of today talking about, these are kinds of questions that come up a lot in real life. And the person asking these questions might be a graduate student who's trying to spin up on their first serious research project. It might be a seasoned scientist who's just jumping into some new types of data or new types of questions, or even just moving from a legacy, set of computing tools. How do you get started? How do you know what to use? How do you go from teaching examples to real examples on real data sets? And then, how do you actually implement the details of a calculation? When we read a paper, we get typically only sort of a high-level description of how a calculation is really done. And as we know, there's a lot of important details that don't always make it into the peer-reviewed literature. And then this idea of reproducibility, how do I make sure that the analysis code that I come up with doesn't just work now, but has some hope of being still useful a year from now, 2 years from now, and so on. So a lot of us who came through grad school in science and in geoscience in particular, we faced questions like this, and the answer was essentially ask around. It's talk to people in your lab group. It's talk to your advisor. It's get scripts handed down person to person. And I just think that there's a lot of ways in which that kind of insider knowledge approach to how to actually do science, frankly, just gets in the way of doing good science. And the Pythia Cookbook Initiative is kind of organized around maybe we can do this better as a community. So a better future that doesn't rely so heavily on just knowing who to ask these kinds of questions to. Crowdsourced best practices that are curated and maintained in some kind of findable, open, inclusive community archive. And that archive perhaps backed by some actual computation. So there's some promise of reproducibility. So when you look at teaching examples, they just work, they're maintained, and they continue to work. And they also give you potentially pathways to scale up from the teaching examples to actually doing some new science. So that's kind of, in a nutshell, the vision of what we think of as cookbooks. So we take collections of recipes for transforming raw data into some kind of expressive results. When I talk about cookbooks for the rest of my talk here, this is what I mean. So Pythia has been active in this space for a couple of years now, and if you go to cookbooks.projectpythia.org now, that's where you'll find this gallery, and this is sort of our prototype of this easily findable, searchable collection of community-maintained high-quality recipes. I just counted. I have to keep updating the slide because it is growing. 19 cookbooks. If you drill into them, you'll find about 108 individual chapters inside those books. Each chapter is essentially one notebook of content, and it's growing. And if you look through the gallery, you'll find, and the screenshot just shows you, the first few titles. You'll find books that are organized in some different ways. Some are very explicitly organized on a science topic or question. Some are more oriented toward a particular data set or a particular set of tools. What they have in common is some common formatting and structure, and the fact that they're all what we call binderized, right? So there's links to executable environments kind of attached to all of these books. So a small sampling of the kinds of topics that are currently covered in the Cookbook Gallery: climate modeling, remote sensing, radar meteorology, et cetera, et cetera. It's also the case that if you start drilling down into repositories that exist and have some content in them but haven't quite made their way into this gallery yet, there's about 20 more, about double the number of these books that are in various stages of in the works. And a lot of that actually originates from the hackathon we had this past summer, which I'll say something about in a few minutes. Okay, I want to just spend a little bit of time just talking about some of the technical machinery here and more, but kind of from a high level. Like, what are we trying to do? What is Project Pythia trying to provide as tools to the community that enables and encourages people to come and participate by way of bringing their knowledge, their disciplinary skills, their analysis code, and putting it in a form that's useful to the community. So I like to think of this as this sort of publication machine. Here's the idea that as an author of cookbook content, I'm over on this side. I have notebooks that do something useful with the data that I'm working with. So that's my content. I don't want to have to be an expert in a lot of the tools that underlie how we take those notebooks, render them, and publish them. Everything in this box ideally is kind of a black box to the average contributor. So what I'm dealing with is a GitHub repository that has a bunch of boilerplate in it that drives all of this machinery that comes from a template that Pythia maintains. And I should be able to come in and put my notebooks in, put in some environment descriptions, some minimal configuration, and then that goes into this pipeline. And actually what happens then, and this pipeline executes frequently because anytime I push any kind of changes into this repository or open a pull request or even just on a schedule for some health checking, we're taking the raw notebooks that don't have any results in them and fully executing them. And one of the key pieces of this pipeline is a call out to a binder service that currently we have something running on the NSF-funded Jetstream 2 that is able to take notebooks from cookbooks in a dedicated environment that's described in that cookbook repository and just execute everything. And then we use Jupyter to package it up into nice looking web pages. We use GitHub to publish them. And so the output of this pipeline are these nice looking searchable, findable web pages that have these binder links embedded in them and so on. So again, this pipeline runs every time I do something to that source repository. And that includes if I come along as an outside contributor, open a pull request. The nice thing is that I can put a new notebook or a modification to a notebook in, and I can actually see as a preview the kind of end result of the real pipeline that's used to build these books. So, having built some of this infrastructure that is intended to sort of simplify the process of someone who doesn't have a huge amount of knowledge about all of those intermediate steps, but just has some scientific content that they want to contribute to this community resource. We want to invite people to come and do just that. And we want to create spaces where there's a lot of knowledge sharing going on. And so we have, as part of the NSF funding that we're currently operating under, we have some funds to run these annual events. So we had a really nice meeting in June of this past June at NCAR in Boulder. And here's some pretty pictures from that event. But we had something like around about 50 people in person, plus a sizable contingent of online contributors. And so we had a pretty rich set of breakout groups that were organized around cookbook topics. So we had small group work where people were collaborating and skill sharing in terms of like going from an idea to a finished book. And that was a great week, lots of energy, lots of enthusiasm, and lots of new people coming in that weren't, that had never been to a hackathon before, for example, and many who were just learning how to do things like open a pull request and so on. So really kind of taking their first step into participating in open source workflows. And we were able, in varying degrees of success, able to create breakout groups that had sort of mixed, diverse groups that were able to sort of self-mentor through those series skill acquisition. So we're going to do this all again. We learned a lot of lessons on what worked well and what could be improved. We're going to do this again this coming summer. So this is kind of a save the date. Early August of summer 25, we're going to be doing this. And then we have one more year in this grant cycle. So we're expecting to do yet another hackathon in summer 26. I wanted to mention one of the exciting things that's coming soon, and this actually was something that came out of last summer's hackathon. A lot of effort went into kind of launching this new collaboration between sort of the core Project Pythia folks and some others from Executable Books Project, CurveNote, and 2i2c to sort of figure out what does the next generation cookbook infrastructure actually look like. And here we're leveraging this really exciting advances in the world of sort of open publishing tools in the MIST project. So MIST Markdown has developed basically what's going to be the next generation of Jupyter, the next set of tools that let us bring science content and package it into really documents that make for great communication. And I'm excited about a number of things. What I'm showing you in this screenshot is just an example. There's a whole repository full of these prototypes now of what are existing Pythia cookbooks that have been translated to this new MIST-based framework. And in many cases, that work was actually remarkably easy to do, and the books are improved as a result. So they look better, they're easier to navigate. I think from my perspective, trying to grow this collection and this community, one of the key features here is that the next generation of the cookbook infrastructure is just going to be nicer to work with, a lot closer to the goal I expressed earlier, which was, can we just invite people who don't know a lot about how these online publishing and execution tools work and just have them bring their science and plop it into a template and have that be something that people can effectively collaborate on. I think we're going to get a lot closer to that with this next generation of infrastructure. We're also going to remarkably reduce, I think, the amount of maintenance that's needed to keep all the cookbooks running, just because of some sort of smart centralization of some of the kind of boilerplate configuration information, though the individual cookbook repositories are going to get a lot leaner after we finish this transition, and that's going to be a good thing. So I want to throw these things out just as discussion points, basically. So I think Pythia has been doing some great work. I think it's been having an impact and making some progress towards some of the stated goals of providing pathways for people into a more open science approach and building up what are valuable resources that are there for the community to learn from. But things are still hard. Some things are hard. So this is my very opinionated take on things that I wish were easier. So it's still too hard for a newbie to come along and just get involved in the sense of, again, I have some content, I want to make a cookbook. How many different sets of technical skills do I really need to master before I can do that? Like I said, I think the next generation of our infrastructure is going to address some of that, so I'm excited about that. What we found in running these hackathons is that collaboration through GitHub pull requests when we're dealing with these mixed media like notebooks, it can be quite daunting, and it's not always clear that GitHub pull requests are really the right way to do those collaborations. So I just feel like there's a missing tool there, something that's more like Google Docs for notebooks, that makes collaborative work more straightforward, would let people come into an event like a limited time hackathon and do a lot more. There's counter arguments there about the value of spending that time developing those skills and building that confidence, but I think the point remains that we could get a lot more actual content built if we could lower some of those technical barriers. One thing we're dealing with right now is this this getting across the finish line issue. I mentioned we have about 20 works in progress, doubling the size of the existing gallery of cookbooks. It's People are very excited. We've been really happy to see the enthusiasm for people to come to these summer events and spend a week, collaborating on this project. But most projects don't get finished in a week. And it's really hard for everyone, all of us, to carve out time to finish your pet summer project when you go back to your day job. So that's kind of connected to the last bullet about incentivizing. So I guess I should have reordered these bullets, but broadly speaking, it's easy to convince people of the value of a well-organized, well-maintained, curated cookbook gallery, but it's harder in the day-to-day to convince people that it's definitely worth their time to go in and make those contributions and make the sustained contributions that are necessary to keep things maintained. And so and this is a very broad question, but how do we as a community make the incentives better? And I call this soft scholarly work, in the sense that I think we can and should treat things like cookbooks as scholarly objects, and we do put DOIs on them when they're published in the gallery, so they are citable and traceable to their authors and so on. So we've put some effort into at least making it possible for people to put these things on their CV and have them tracked. But that doesn't solve the problem of how the rest of the world views those types of contributions. So that's a big problem, and one that I think Pythia would love to engage with bigger communities about. What should we be doing to solve that problem? And then the last bullet here is, and it's connected to everything I just said, it's this idea of maintenance. You know, we want this gallery to work. The whole promise here is that you come any day of the week and click one of those execute buttons and you find code that runs and code that provides an actual starting point for solving your problem. And we have technology in place to help with the finding where things break, right? But the fixing things that are broken is kind of the harder part. And you know, whose job is it to fix the thing that's broken is kind of a complicated question, and it comes back to this question of incentives. You know, to some extent, we have some funding for the project, so there are some actual resources that we can bring to bear in terms of people time to fix the technical problems. But as this community content grows, you know, who's going to do the work as, you know, we go from NumPy 2.0 to NumPy 3.0 and more things break, you know, who's going to do the work to go modernize the code examples? You know, these are more questions than answers right now. But I think the vision here is that we build a broad enough coalition of people who find value in what's in that gallery, that they get interested in being part of the ongoing conversation about how to keep it vital. This is my last slide. I don't need to read through all of this, but this is just a bit of a roadmap. I've touched on a number of these points already. We're going to keep doing the hackathons. We have some stuff in the works on the technical side about growing and diversifying the sort of cloud-based services that we're using to do the cookbook execution and development and testing. We have some money in this NSF award to work on that. We have a funded partnership with 2i2c that is going to lead to some specific advances in that sort of cloud infrastructure side of things. The other parts of the problem are more sort of social problems, right? This idea of incentivizing treating cookbooks as scholarly objects, and then the governance question. How do we make sure Project Pythia is responsive to the actual needs of the community? And so I'd love to, you know, just throw all that out as discussion points, and I'll stop there. So thank you.
All right. Thanks, Brian. I'm going to stop the recording.